Hello viewers, welcome to Elimu TV, a place where you watch and learn. I am teacher Alex Musawa and I'll be taking you through Physics Form 4, lesson number 29, titled Hard and Soft X-rays. What are the objectives of this lesson? Number 1, to know the difference between hard and soft X-rays, to list the uses of X-rays and their dangers. Hard X-rays and soft X-rays. Number 1. Hard X-rays, they have a shorter wavelength, and soft X-rays have a longer wavelength. Okay, how are hard X-rays and soft X-rays produced? Hard X-rays are produced by fast moving electrons as a result of a high accelerating voltage. Soft X-rays are produced by electrons moving at a relatively lower velocities than those that produce hard X-rays. Their differences. Hard X-rays, they have a shorter wavelength. Soft X-rays have a longer wavelength. They are more energetic, and the soft X-rays, they have less penetrative power. They have a high frequency, and the hard X-rays and the soft X-rays, they have a low frequency. The hard X-rays are produced by high voltage. The soft X-rays, they are produced by low voltage. And lastly, the hard X-rays, they are produced by fast moving electrons, and the soft X-rays are produced by slow moving electrons. What is the intensity? It is the total energy contained in a beam or product of quality and quantity of X-ray photons. The greater the heating current, the greater the number of electrons produced. Hence, the more X-rays, the strength or the quantity of the X-rays will, however, remain the same. The strength of the X-rays depends on the speed of the electrons, which in turn depends on the accelerating potential difference between the cathode and the anode. Next, we have uses of X-rays. They are used in medicine. As you can see, they are used in hospitals and medical research centers for diagnosis and treatment of diseases. The diagnosis involves a process called X-ray imaging. As you can see from the diagram, that is what we call X-ray imaging. The X-rays are allowed to cast a shadow onto a photographic film. Examination of the photographic film reveals the injury or the infection of the tissue. For example, if someone has a broken limb, we take that person through an X-ray, and the broken limb can be revealed. And also, diagnosis of softer tissues such as lungs, liver, spleen, or the heart or the kidney can also be used. Next, they are used in industries to detect flaws in metal castings and welding. The radiation is also used to sterilize surgical equipment before packaging. Next, they are used to study the crystal structure of substances. The regular arrangement of atoms within a crystal produces diffraction effects when X-rays are passed through it. This is because a crystal has regularly arranged atomic planes which are very close together. Next, they are used in airports. X-rays are used to inspect luggage for any weapons that may be hidden in them. For example, in these times, you know that there's a lot of terrorism that goes on in our world, and people pass in the airports. So, X-rays are able to detect hidden weapons in bags and things that are unwanted in the airport. Next, we have dangers of X-rays. Excessive exposure of living tissues to X-rays is dangerous, as the radiation can damage or kill cells. Since the effect of exposure is cumulative, it is important that exposure be limited to as short periods. And that is the end of our lesson. I have a question for you. Number 1, list 5 differences between hard X-rays and soft X-rays. Number 2, list 4 uses of X-rays. Our reference comes from KLB Book 4, Physics 5th edition, 2019. For more information, contact us on our phone number, on YouTube, Elimu TV, on Facebook, Elimu TV, and on Twitter at Elimu TV_KP. Thank you for watching Elimu TV. Stay tuned.